everyone. Well, today we are going to continue our learning journey with functions and graphs and talk about how do we analyze graphs. So we talked about linear functions and we've talked about nonlinear functions and how sometimes graphs can have constant rates of change and not constant rates of change. So today we're going to be looking at the rates of change and we're going to be analyzing them or putting meaning behind them or using the meaning to help us make our graphs. So when we're analyzing graphs, we are looking for the relationship that's being shown. So graphs can show a relationship, which is what we've been looking at. But this relationship that we're seeing is a relationship between quantities so like amounts. So quantities without using specific numbers and the axes. Okay, so we're looking at quantities without using specific numbers and the axes. So that's the relationship that we're going to look for when we analyze graphs. So let's take a look at an example. So let's say that we have example A, and example A asks us to describe the change in temperature. All right, so when we look at the change in temperature, we're going to start out by looking at some different pieces. So relationships up here. We could have a graph that looks like this, and we might have three different parts to our graph. We might have an increase, we might have no change or a constant because it's flat, and then we might have a decrease. So let's label these different parts so we can use these words to help us describe. So a decrease, the flat is no change or constant. And then last we have this part here, which was the increase. Sorry that is so small. I should have made that bigger. Okay, so we have different parts. So we're going to use these words to help us describe the change in temperature. So our first graph that we are going to be given looks like this. And the line that is on it looks like this. Okay, first of all, we know that this is a non-linear function, right? So this is non-linear, and it's non-linear because one, it's not a straight line. Two, it's non-linear because also it doesn't have a constant rate. So it changes in its rate, right? So we can describe the temperature by looking at the axes. So this one here, this one shows time. And this one here, the y-axis, shows the temperature. All right, when we're reading graphs, we know that when we start at the origin, the temperature then possibly could be 0. And then as we move up the y-axis, we know that our numbers are getting bigger or they are increasing, right? As we start on time, we start at no time, and then we work our way to increasing the amount of hours or days or I don't know, minutes, however long the time is. But again, when we're looking at analyzing graphs, we're not looking at specific quantities. We're just talking about what's happening using the words increasing, decreasing, and no change. So we can start at time being like the beginning of the day. So what's happening on this graph? So what's happening on this graph is that at the beginning of the day, the temperature increases. So we could say the temperature increases at the beginning of the day because it's going up. So here's one of our words that we would use, increases. At the beginning, because the beginning of time is here. And then what happens to the graph? Well, as the day goes on, the temperature starts to drop or decrease, as the day goes on, right? So it decreases once it reaches its maximum temperature. So it goes up and then it starts to decrease at a really fast rate. So we could say it then decreases at a fast rate. And we know it's a fast rate because it's just dropping straight down. This is a gradual incline and then boom, it just goes straight down. So that means that it's fast. This one's gradually climbing and then a drop. Okay, so you've described the temperature. Okay, let's look at another graph and we'll describe the temperature of this graph. Okay, so this graph looks like this. Here's your graph. And in this one, the temperature starts here, goes down. Okay, so there's your graph. Again, time is on the bottom. And then we have temperature. Okay, we can describe what's happening in this graph by just looking at the line, right? So we know our words decrease, right? When something goes downward, it's decreasing. So here, the temperature decreases. So also, what's different between this graph here and this graph here is that the decrease is constant. This one was really fast. So this one, you can tell it's constant because look, it's a straight line and it has the same slope. So here's where that slope is going to come into play that we learned about. So the temperature decreases, so at the beginning of the day, oh, there's that pink pen I should have thrown away a while ago. Okay, beginning of the day, the temperature decreases or goes down at a constant rate. Okay, that's where that slope comes in. Then what happens? The temperature is going to stay the same for a while, right? So here's the start of the day. The temperature is going to, stay the same for a little while, and then it's going to start to warm back up. So at the beginning of the day, it's a constant temperature, or constant decrease, I mean. And then, so here's this part. It's decreasing. And then we have constant. And then it warms back up. You can think of it, you can think of this like we start out on a nice warm spring day. The rain comes and cools everything down. And then the sun comes out and it stays constant, like 60 all day. And then, ooh, we get a heat wave, right? And then it goes up to maybe like 65 before we could say it could start dropping again for the nighttime. This right here can describe Washington in the spring, no problem. This could describe Washington as well. Winter, warms up, drops back down again. Okay, so we have many different ways that we could discuss how the weather is happening here. But the graph shows the various temperatures and what's actually happening within those cities. All right, so I'm going to turn my page now so we can look at some other examples. All right, so the next example that I would like to look at is a picture of like they're going to give you something that says a subway train is stopped and then it gains speed at a constant rate until it reaches its maximum speed. So you have to actually draw what's happening in the picture. So in this example, you have to draw what's happening and based on what it's showing. So they'll give you the graph and you make the lines. Okay, so first it says that a train gains speed. So one, it's stopped, and then it gains speed at a constant rate. So what does this actually look like? Okay, so step one, we have a train and it's going to gain speed. So if we had time here and we had speed here, just like last time, but we had temperature there, we would start, if it's stopped, it's not going anywhere, right? So it's at 0. So we're going to stop at 0 and we're going to gain a constant speed until we reach our cruising speed. Okay? Then the next part is that it gains a cruising speed. So you've seen trains go, right? And they just cruise for a while, right? So then we have a cruising speed. So cruising speed would be going at a constant rate, just flat. There's no change in the amount of speed. It just stays the same the whole time until it starts to slow down. So the last part of this is that the train is going to slow down until it reaches the train station. So slows until it reaches the train stop. Okay, so this looks like a constant rate, right? Trains slow at a constant speed. They don't just stop abruptly. So we're just going to draw a train slowing down until it doesn't move anymore. So here you have the increase in speed right here. Here you have the cruising speed of that train. And then last part of your graph is slowing until it reaches a stop. Okay, all right, let's do some triads. So we're going to do 2 triads right now. And on your triads, the first triad, I'm going to give you the graph and you're going to explain to me what's happening. And then on the second one, I will give you the words and you will tell me what happens to it. All right, so let's go with this one. All right, so triad number 1 looks like this. Can't see Okay, that's the first one. We have time here, and we have temperature here. So explain to me what's happening with this graph and the temperature. Okay, the next example that we are going to look at, the next try it, you are going to draw me the graph based on this description. So let me give you a description here. A fully charged battery loses its charge at a constant rate. Okay, so it's fully charged. And then it loses the charge at a constant rate. You plug it in and you reach a full charge again. All right, so you are going to show me what this looks like. So 1, tell me what's happening, and 2, draw me a graph that shows full charge, losing charge at a constant rate, and then plugging it back in until it reaches a full charge again. All right, go ahead and hit pause so you don't hear me speaking, and then hit play when you're ready to check your work. Okay, so the temperature here, it looks like it's slightly increasing. So 1, we have a slight increase in temp. And then it looks like the temperature drops rapidly. All right, so you have a slight increase. It slightly rises, and then it drops rapidly. So whatever that looks like. Okay, this one here, so let's go ahead and move this up. This example, we have a full charge, and then it's going to lose its charge at a constant rate until you plug it back in. So let's draw our graph. All right, so we have charge over here, and then time here. So how much battery percentage we have versus how much time we have on the battery. All right, to find. Okay, so we start out charged, and then we have a loss at a constant rate. Okay, and then we plug it in until it reaches a full charge, and that's going to be constant. So it looks like that again. So you have something that looks like a giant V. You have your decrease, and then you have your slight increase. All right, how did you do on today's lesson? Go ahead and rate yourself out to the side and answer your essential question. How do we analyze graphs? All right. If you have questions, come on back to the Google Meet. Otherwise, you can head on to Big Ideas and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.